Ashita, start.
Good morning, everyone. I'm Ashita, first year undergraduate and student representative of ChemPlus. Welcome to the inaugural ceremony of ChemPlus. Today with us, we have Dr. R. Ravi Krishna, HOD of Chemical Engineering Department, IIT Madras, Dr. Rajagopalan Srinivasan, Conveyor of Chemical Engineering Society, IIT Madras, Gunavardhan, Undergraduate Secretary of CHES, Sabnik, Postgraduate Secretary of CHES, and Soumya, AICHE President. Now, I would like to call upon Dr. R. Ravi Krishna, HOD of Chemical Engineering Department, to give us insights on the achievements and milestones of the Chemical Engineering Department.
Good morning and welcome to ChemPlus 2022, the technical symposium organized by the Department of Chemical Engineering. As chemical engineering, the programs organized by this team in ChemPlus, I think, cut across a very wide variety of aspects. Chemical engineers are involved, which includes almost everything where you can call something a process. I think chemical engineers are involved. So pretty much everywhere. Okay. So chemical engineering department here at IIT Madras, as I think if you look at our website, very wide range of topics people work on, and both research application, and it is also increasing, and we also strive to get ourselves even broader avenues and provide better opportunities for our students, and both PhD, masters, bachelors. In the ChemPlus, we have we kick off today with 2 lectures in the area of that are great current need and interest. That's on water and carbon itself, and then it's related to sustainability. And this, I think, is, in my opinion, very important, great urgent need focus for all engineers, not just chemical engineers. That's going to be the challenge in the future, near future as well. So the ChemPlus, I guess there are a lot of other fun and games in the schedules that I see, along with some very interesting and very useful workshops. So we all hope that this event will be in person next year. But as we have all evolved over the last 2 years, we have, I think, we have coped and made the best of what has been given to us in terms of opportunities, and we'll do the best of that. And we'll strive to do the same in the ChemPlus online version this year as well. Okay. So I wish all the participants and the organizers a good experience over the next 2 days, and hopefully it will be useful and benefit you in the current and in the future, in your future endeavors. I forward the best wishes of all my colleagues and staff and other students for ChemPlus 2022. Thank you very much.
Next, we have Dr. Rajagopalan Srinivasan, Conveyor of CHES, who will be giving us an overview of the events, lecture series, and Chemi Panel.
Good morning, everybody. Welcome to this 2022 edition of ChemPlus. ChemPlus in its current form is about 5 years into its maturity. Previously, we used to have 2 separate events, one primarily focused on undergraduate students, another one more on graduate and research students. Over the last 5 years or so, these have come together, and that reflects in the program of this event. Like Professor Ravi Krishna said, 2 years ago, when COVID just started, we had managed to squeeze through ChemPlus 2020 before we went into lockdown. Then subsequently last year, we had to have a virtual event. And if we are lucky, this year's would be the last virtual ChemPlus before we return back to in-person ChemPlus next year, we hope. So all of these ChemPlus events have had fairly good participation from around India, certainly from most of South India, and many city colleges, city universities, Chennai-oriented ones, always like to come, spend some time in our beautiful campus in the heart of the city. What we have in store for you in the next 2 days is a mix of fun, expanding your horizons in terms of current topics, and obviously, activities where you can show your skills and your, your passion. So right after this inaugural ceremony, like last time, we are going to have a Chemi panel. The Chemi panel is an event where we invite our own alumni, chemical engineering department alumni from IIT Madras, who have been in their careers for anywhere from 1 or 2 years to all the way to perhaps even 30 years, and ask them to share their journey and how chemical engineering has enabled them to get to the great heights that they now occupy in their own professional career. So this is set up as a panel. I'm sure the panelists would really want all the audience to pitch in with questions and be very engaged. After the Chemi panel, we have a couple of talks, like Professor Ravikrishna also alluded. Today we are focused on sustainability. So the two talks today, one at 10:30 and the other one at 5 p.m. Are going to talk about water and then carbon capture. We again have a third plenary, which is tomorrow at 5 p.m. and that would be on the role of chemical engineers in the semiconductor industry. So all of these being new and upcoming topics for a career in chemical engineering in India, we believe that you will all gain a lot from listening to people who have spent their entire life in these verticals. Besides this kind of heavy stuff, we also have lots of workshops. I think our MATLAB workshop, our Fluent workshop, and our data science and machine learning DSML workshop have always been very popular. They are always oversubscribed and we are forced to sometimes turn away people. So I'm sure, again, those of you who have not had a chance to register yet, it might probably still not be too late. Feel free to contact the organizers and they will try to squeeze you in if you're interested. So that's kind of the mid part. And then the fun is, there's always a lot of fun in ChemPlus, whether it is in person or online. And again, the number of activities, quiz, crossword, gaming, and so on. And finally, on Sunday, we save the whole day for in-depth technical presentations. Both the graduate research scholar students and our own undergraduate students who are doing cutting-edge research, they would all be presenting technical papers on 4 different topics. We have had a very good reception to our call for papers, and we have had a difficult time identifying the small number of papers we are going to have present during this event. So I'm sure that you will find all the papers are of high quality and they will certainly germinate some new ideas for you if you're especially interested in taking up research. So with that, again, a warm welcome to ChemPlus 2022. I look forward to seeing you all over the next 2 days. Back to you, Gunu.
Now, I would like to call upon Gunavardhan to give us a brief idea about the activities conducted by CHESS this year and his experience as the undergraduate secretary of CHESS.
Good morning, everyone. As the secretary of Chemical Engineering Society, IIT Madras, it gives me immense pleasure to welcome you all on behalf of the entire organizing committee to the 15th edition of ChemPlus. Over the years, the Chemical Engineering Society has organized a series of events that capitalize on our strengths and that are built on our commitment to promoting chemical engineering. As the undergraduate secretary, I had the opportunity to learn, collaborate, exchange ideas, and also have fun bringing this best to you alongside highly motivated and enthusiastic individuals. I believe ChemPlus 2022 will reinvent your interest as chemical engineers. Let us begin our celebrations for the next 3 days, which are loaded with knowledge and fun. With this, I thank you all and wish you all the very best.
Now, we have Sagnik, who will be taking us through this year's CHESS events and sharing his experience as postgraduate secretary of CHESS.
Good morning, everyone. A warm welcome to all participants, members, mentors, and others attending the ChemPlus which is the annual technical fest of Chemical Engineering Society. CHES proud to host the 15th annual edition of our technical fest, ChemPlus. ChemPlus has combined the engineering as well as the research symposium in the current years. There is no role more participant and vital as that of a chemical engineer. We at ChemPlus celebrate the spirit of inquiry and innovation and emphasize the significant laid by chemical engineers in day-to-day life. We cordially invite you to participate and boost your knowledge as well as technical expertise. Over this span of 3 days, ChemPlus provides a plethora of events ranging from informal events like quiz, technography, to research symposium through paper presentation. A number of eminent personalities will be entitled to motivate the youth through their plenary lectures in these 3 days. I wish all the best to the participants and to all those who will be attending the campus. Thank you.
I would like to call upon Soumya, AICHE President, who will be sharing his perspective on how AICHE strives to promote chemical engineering.
As the Students President of AICHE IIT Madras Chapter, I'd like to give a cordial greeting to all ChemPlus 2022 participants and attendees. AICHE IIT Madras was founded with the goal of promoting chemical engineering as a professional career with transdisciplinary possibilities. We have received great comments from all student communities and academics throughout the years, and we hope to keep the same enthusiasm alive and make it worthwhile. With this, I'd like to conclude the inauguration ceremony and declare ChemPlus open for action. Thank you.
Guna, we can start as soon as you're ready.
Yes, sir, I think we are ready.
Okay, good morning, everyone. I'm Himanshu. I'm an assistant professor at Department of Chemical Engineering. So today, the first event of our day will start with the Chemi Panel discussion. And the purpose of this panel discussion is to inform the students who are pursuing chemical engineering that what could be the different types of career opportunities they can look forward to after graduating from IIT Madras. So for that purpose, we have been doing this event every year. And this year also, we have a good mix of our panelists who all of them are alumni from IIT Madras, batch of 93 to batch of 18. So, and they have been working in different areas of life. So we will see that in today's panel discussion, what could be the different opportunities you can look forward to after your chemical engineering. So I'll introduce our panel members today, and then we can jump into asking them questions and see where the event goes. So we have Dr. Balaji Agoram, who is from batch of 93, and he's currently Vice President at Arcus Biosciences. We have Praneeth Sriwant, who is a research engineer at C6 Energy. He's from batch of 18. We have Santosh Davare, who is currently pursuing PhD at IIT Bombay and Monash Research Academy. And Santosh did his BTech from, graduated in 2014 from IIT Madras. We have Sanjay Kumar, who is currently associate at JP Morgan, and he did his BTech in 2018. And we have Dr. Akshaya Sundar, who is currently a process engineer at Voyex PV. She pursued her MTech from IIT Madras and graduated from here in 2017. So I'll cordially invite all the panelists to participate in this discussion, and please enlighten the our Chemi students who are pursuing chemical engineering as an undergrad or as a master students to inform them what could be the possible opportunities that they can look forward to after graduating from IIT Madras. So to conduct this panel discussion, along with me, I have two student volunteers, Hari and Mahita, who have compiled a list of questions after consulting with their friends. What are the common concerns they have during their studies regarding the possible career options? So I'll invite also Hari and Mahita to maybe start with a simple question for our panelists.
Good morning, everyone. So there is one icebreaker question for all of you. Did you choose IIT Madras Chemical Engineering branch based on interest or based on rank?
It seems like a nice forming question.
So Mahita, maybe you can choose which panelist member you want to start with. And
Praneeth Srivan.
Yeah. Hi, good morning, everyone. My greetings to all my co-panelists and other members of the audience. So for me, back in 2014, for my IIT rank, there were a bunch of options in other IITs, for instance, mechanical and electrical engineering, but I was keen to come to IIT Madras and I was keen for a BTech degree. So that ended up, only BTech chemical engineering was possible. But it was a happy mix of both, I should say, in the sense my interest and rank, because after my first semester, while I was eligible for branch change to any department, based on my CGPA, I continued to be in Chemi only.
Yeah, thank you. Next, Balaji Agoram.
Hi, can everyone hear me? Yes, no? Okay. I'll assume you can. So, thank you. Thanks for having me. Good morning, good evening. I was in my 12th, back when we were doing JEE, I was actually good at chemistry. That was my strong subject. So I had this weird affinity to chemical engineering. So I was very happy when I got a rank that actually allowed me either Chem or Mech. And I was really interested in chemical engineering. Only after I joined, I realized that chemistry had nothing really to do with chemical engineering other than one extra semester of chemistry back then. So yeah, it was a happy coincidence of both perceived interest and rank.
Thank you. Next, Santosh Davari.
Good morning, everyone. Thanks for inviting me here. My answer to this question is I took this balanced decision due to my interest in chemical engineering and as well as rank. I got admission in ICT and IIT Madras, but I wanted to have different exposure. I wanted to leave my state. I wanted to be in South India. I wanted to visit Madras, and that's why. And specifically, I saw that when I evaluated chemical engineering as a profession, I saw that chemical engineers are everywhere. They are like in pharma, they are in like oil and gas. So, and I see that their contribution is little unique. That taking a product from a lab scale to pilot scale. So this scale up aspect was really enjoyable, and that's why I chose chemical engineering and specifically IIT Madras.
Thank you, sir. Next, Sanjay Kumar.
Good morning, everyone. Am I audible? Okay, cool. So in my case, as a kid preparing for JEE in Chennai, so I had a strong preference for IIT Madras, but at 17, I didn't know what each branch meant. So I had a broad idea, but I didn't know much about the details of what each branch would do. So what do? You look at the publicly available information, you speak to your seniors. That's what I did. So when I looked at what are the core courses each department offers, they looked very similar. Every department was offering a fluid mechanics course. Most departments were offering a heat transfer course. So that just increased the confusion. And then I ended up speaking to a few seniors studying here at IIT Madras. And then one good thing about chemical engineering as a department is that no one had anything negative to say about the branch, which wasn't the case for all branches from my personal experience. So that's how I ended up choosing chemical engineering.
Thank you, sir. Next, Akshaya Sundar ma'am.
Hi, good morning, and thanks for inviting me as well. So for my case, it was also based on pure interest in chemical engineering, not based on rank. I was, I mean, as Sanjay said, I was also not very sure about other branches, but I was sure that I don't want to pursue something in electronics, computer science, civil. So the rest of the options was biotech or chemical. And thankfully, I had one of my cousin who was an established chemical engineer by then. So he had guided me through this program. So that's how I ended up in chemical engineering. Plus, I thought it's really cool at that time, to be a chemical engineer. So,
thank you, ma'am.
There is an old saying that you don't choose chemical engineering chooses you. So I'm glad that I'm proven wrong, at least in this panel. So there are people who have selected chemical engineering, if not as their first choice, but they had inclination towards chemical engineering. So that's good to start with. Yeah, Mahita, you can go.
Next, Harikarthik will continue.
Pleasant morning, everyone. Next, we'll move on with the next general question. What factors should you consider when deciding whether to work with a well-known corporation or a startup? First, I would like to invite Praneet Shrivan sir to express his opinion on this question.
Yeah, you can call me Praneet. No need to call me sir. Yeah, it's a very interesting question. In the current age when a lot of people are going towards starting their careers in startups and small companies. So rather than giving a blanket advice kind of thing, I can talk from my personal experience. Back during my undergrad time, I spent 6 months for my final year project at Shell R&D, one of the big companies in chemical engineering. And the experience in R&D I had over there was very different from the startup experiences I have had in a lot of the small startups that were there in IIT Madras Research Park. So to say even in startups, the companies are across different scales. Like there are startups where there are just some 8 or 10 people, and there are startups where there are some 30, 40 people and 80 people. And the company where I'm working right now, C6 Energy, is slightly a bigger company. So, it's very difficult for an undergrad student to kind of go towards any one of them without having a notion of what it would be to work in all that. For instance, in bigger companies, there's a lot of structure. There are opportunities to explore a lot of different projects. In smaller companies, the team is kind of limited to certain core ideas, what they're doing, but then there's a lot more autonomy. One can kind of, innovate and do things, implement things in a faster manner in smaller companies. So I would encourage anyone who's kind of confused to test waters by doing internships during the 2nd or 3rd year, maybe a winter internship in a startup, a summer internship in a corporate, something like that. That would be a good way to go forward.
Thank you. Next, I'd like to call Akshay ma'am to answer the same question.
Sure. From my experience, I can share. So currently, I work in a startup, and just to clarify, I did after my master's in IIT, I did not do the PhD, for instance, but it's called a professional doctorate program in Netherlands. So which is a really industrial oriented, PhD kind of program. But it's a 3-year program, which I did both in biochemical and chemical engineering department with a specialization in process equipment and design. So during the program itself, we are introduced into different kinds of industries to do many projects. So basically to solve all kinds of problems that can arise in any industry. So as you see, I didn't work much in India. So I'm sharing my experiences in Netherlands. So I had an opportunity to work with Tata Steel in Netherlands and DSM, which is a biotech company, and also Shell. And later on, I worked in a startup, or I ended up in a startup after my thesis. So from working in different, both companies, like big companies and startup, I would say like you have to consider your personal aptitude and interest as a main factor before choosing into what. So as a startup, depending on whether it's a small startup or an established startup, you can face like stability issues and much more challenges than an established company like a Shell or like Tata, whatever. So there you can have like more stability, more organized structure, and guidance from seniors or who are like very experienced, which you will lack in startup. So, but that's up to your personal interest. So after working in big companies, I had an affinity to work with startups because I thought, okay, I want to be more creative and like I want to expand these things or the chemical engineering skills which I developed in startup. But as I said, it's depending on you. Some people would like to work in a bigger group, more stable environment without having to worry about, like a consistent everyday challenge. But some people are really keen to do more challenging jobs, working in startup where they can push their limits. So I guess you don't have to compare with others or to follow the crowd, but it's just depending on you, what you want to pursue, and you can choose. And both like sector, you have an immense opportunity to grow yourself. So it's all up to you. That's what I think. Thanks.
Yeah, thank you. Next, we'll move on to Balaji Agaram.
Yeah. So, yeah, I worked for many years in big pharma. So a number of big pharma, Pfizer, AstraZeneca, and then over the last 7 or 8 years, I've worked in small biotech. So real small startups, like 10, 20 people. So I think culturally they're quite different. So I want to echo everything that others said as well. You made some really important points that I want to reiterate. So, you have to know where you will be comfortable. So either if you can take internships or look for other opportunities to see which culture fits you better, I think that would be helpful. But just looking into the culture, and again, my experience is limited to pharma and biotech. So in a big, well-established company, the depth of knowledge that you bring in is really important. So there will be something that is expected of you, and you have to do that really, really well. Whereas in a smaller company, it's it's not just your breadth, but also is depth, but also the breadth of knowledge, right? Because there's always other problems that there is nobody around to solve. So there is an unset expectation that people step up and identify those problems and solve it. So your ability and willingness to learn new things enough to solve problems is going to be really important. And ironically, what I found was in a bigger company, it's very easy to avoid people. Whereas in a small biotech, we have 10, 20 people, you need to have really good people skills to be able to deal with difficult personalities. So, ironically, in a smaller company, I think your people skills become really important. In a bigger company, your organization, navigating a big organization, those skills become really important. So it depends on what sort of personality you have. And then I think Akshay mentioned structured versus unstructured learning. That, again, is very important. So if you're the kind of person where you see something, you're curious about that, you go pick up a book or, that's my generation. Your generation would be watch some YouTube videos or go to GitHub and then learn about it. If you're that kind, then you're much more suited to say, you have the small company, qualities that will make you thrive in a smaller company. Whereas if you're a much more structured learner, then maybe a bigger company is better for you. But in the end, do a little bit of soul searching, do some experimentation. I think everybody should give both a small startup and a big company a go at some point in your career. So early on in your career, try them out and then see what suits you best and then stick to that. And of course, if you're going to a smaller company at any time point, make sure you do your diligence before joining that company. Okay, dig into it, ask the right questions, see how stable they are, see how much cash they have, see what their real, the product is, see if it's really adding value to the market before you jump into that.
Yes, sir. Thank you for your opinion. We'll continue with Santosh Devare.
Yeah, it's a very nice question. I can really relate with it because I can understand the dilemma. I can see that there is a significant difference between well-known company. Well-known company means like which has a higher workforce, and a startup means which is having limited workforce. So before joining PhD, I was working with TCS. So TCS is like 4 lakh workforce, So I would like to bring one point that it is not necessary that well-known companies and well-established multinational companies, you will not get that freedom. There are different settings. You will get enough freedom. If we compare well-known companies with startup, one thing is sure that the sense of ownership you should have. If you want to excel well, you should have a same sense of ownership. And of course, I wanted to build on the previous answers that it depends on your personality. If you are that kind of person who wants to take up challenge, and who is ready to work in non hierarchical, non defined setting. So I have not worked in startup, but I have seen my friends working in startups. So the thing they enjoy doing is because they get different kind of exposure every day. The like in multinational companies where I was working at, I was working on a typical problem. I had a boss, I had a subordinate, I had defined problem, a customer facing, a back end, front end, all those defined things. But in startup, you don't have that. But that itself is rewarding. So if you are that kind of person who wants to invest now heavily and get higher return later, I think you should choose startup. Of course, this stability related concerns are there. Then it is very difficult to know about the future. You cannot predict the future. You don't know which startup will survive, but it depends on your interest. If the problem, the area, the domain they are working is perfectly matching with your background, of course, if the startup may survive or may not survive, you will survive later because you will acquire enough skills and so that you can contribute to the next organization.
Thank you, sir. We'll move on to Sanjay Kumar, sir.
Sure. So I just want to cover two aspects. So back in 2014, when I joined IIT Madras, joining a startup meant taking a big pay cut, which is no longer true. Like, especially in India, we are in the midst of a huge startup boom. With the amount of funding that they're receiving, so the pay matches the big corporates, and sometimes it even exceeds them in some cases. So that is taken off the park straight away. And couple of other things that you immediately recall when you talk about corporates versus startups is whether the brand will be recognized when you leave the job once. So startups have a lot of brand. So for example, it may be the brand of the startup's founder who funds the startup, how famous is the founding team and so on. But this brand value may be limited to a particular region or a particular so everything that I'm talking currently is just an recall. That's just a very small aspect that you should consider while choosing a job. The second, offer you roles that corporates may not, as you're just starting up as an undergraduate. So for example, if you're a researcher, there may be certain roles that can be open only for PhDs, but a startup can offer you such a role. If you're interested in business sort of roles, most corporates would look for an MBA, whereas an undergraduate can work in a startup in such roles. So working in startup definitely has a lot of advantages, for sure. And one main thing that you should consider is that that's already been covered by Akshay and also Dr. Agarom, is that working in a startup can be highly unstructured, and working in the corporate similarly can be too structured and boring. So that's something that depends on your personality, and you have to see where you fit in. So it can happen that you work on a couple of weeks on a project very seriously, and you may be told to set it aside temporarily. This happens in corporates as well, but it can happen more frequently in startups. Are you a person who can handle this temperamentally, and can you handle this on a continuous basis going forward? So it's more about your personal fit. There's hardly to choose just the word corporates and startups anymore. It's about what you get from there that matters going forward.
Yes, sir. Thanks a lot. Now I call Maitha to carry forward.
Yeah, thank you. Now I have individual questions for the panelists. First off, I will start with Balaji Agoram, sir. So what made you choose the pharmaceutical field? Sir, you are muted.
Sorry about that. So, during my grad school studies, I became really interested in the whole medical area, right? So, my PhD was in the area of biological engineering, tissue engineering, which at that time was part of chemical engineering. Now people, say bio or tissue or chem bioengineering. So I became interested in that. And after my PhD, I really wanted to work in something to do with health sciences, right? So I didn't really care. I didn't want to work in a big, petro plant or, one of those chemical plants or anything. So I really wanted to work in the life sciences field, but I was a disaster in the lab. So my work was mostly around mathematical modeling, and at that time there weren't that many options for people, that weren't good in the lab in the pharmaceutical industry. It was still very much an empirical field. But interestingly, pertaining to the previous question, there was a small startup that was trying to create mathematical tools for pharmaceutical scientists to help in their medicine research and development efforts. So, we had met at some conference somewhere, and interestingly enough, when I graduated and I was looking for jobs, that CEO reached out and he said, "Hey, then if you're really interested, why don't you, come over here, give this a go?" It was almost like a postdoctoral job. So, so I started with them, and again, in a lucky coincidence, the whole area of predictive modeling, took off around the time that I joined the industry about 20 years back, and people started seeing, the cost of doing trials and the cost of doing R&D increased dramatically. So people were looking for efficiencies, and the whole mathematical modeling field took off. And so it was it was a fortuitous case of being at the right place at the right time, and I ended up staying in the field for much longer. And the more I did it, the more interested I became in the field. I learned a lot more about how our medicines developed, what are all the steps that are taken, what are the pinch points, what are the inefficiencies in the system, etc. And so that's why I decided to stay in the field, and I never moved on.
Thank you, sir. Can you explain the relationship between the pharmaceutical field and the chemical engineering?
Traditionally, right, so pharma field has been dominated by pure engineers, pure scientists, right, immunologists, microbiologists, biochemists to actually create these drugs, etc. And the one traditional place for chemical engineers is in process development and in these plants for manufacturing of these drugs, so pilot plants, process scale up, etc. And that's still the case. There are still a number of chemical engineers, very gainfully employed in that whole process development, materials development area. But what I'm seeing more and more are chemical engineers moving into clinical research, which is what I am. So I had this department called clinical pharmacology, which is part of the grand clinical research, where we're much more interested in how can we make our clinical trials more efficient. So if I'm treating 5 patients, can I use the data that I generate in those patients and predict what happens when I treat 10 or 100 or 1,000 patients? So that whole idea of applying mathematical modeling to the data that we generate and making the most of the data has become a lot more popular within medicine R&D these days. So that's something that's really, really taking off. And that's a combination of engineering principles and statistics. And if we are chemical engineers, you always have quantitative teaching that's always part of our core curriculum. So applying a statistical wrapper on top of that comes naturally to a chemical engineer. So that area has now got multiple names. You might have heard of PKPD modeling, systems biology, systems pharmacology, etc. So that's become really very popular but niche field within medicine R&D. It's one of the most sought after people within clinical research. And there are other new areas that are coming up as well, which are quite applicable for people with chemical engineering background, which is the use of data science within clinical research. So with the explosion of technologies to gather data, we now gather terabytes of data. I mean, for a 10-patient trial, we now have to create an entire database that's just enormous, but we don't know what to do with these data. So there are a lot of hidden information out there. So mining these data, making sense of the genomics, right, the genetic information in there, along with the phenotypes, so how are these patients behaving, and correlating that with how they're responding to a drug. So these are all really emerging fields. So I predict that in the next 10, 20 years, chemical engineers and indeed other engineers will play a very, very important role in filling those gaps and converting all the data that we have into information that we can use to treat patients. So all these are areas that chemical engineers can fit into, this generation of chemical engineers can fit into.
Thank you very much for your insights. Next, Harikarthik will continue.
Yeah, we'll now move on to Santosh sir. My first question to you is, what's your special interest towards chemical engineering, especially the research and development side? And why did you choose to pursue PhD after working with Tata Research Development and Design Center, TRDC?
Yeah, don't call me sir, call me Santosh. So your first question was, I didn't catch you well.
Yeah. I first asked what's your special interest towards chemical engineering, especially the research and development field.
Okay.
And the second part of that is, why did you choose to pursue PhD after working with Tata Research Development and Design Center?
Yeah. My interest in research and development is in the material science. I was in polymer engineering group. Now it is polymer engineering and colloidal science group. I was working with Professor Basa. So my interest has been along with the same line while I was working in Tata Research Development and Design Center, which is TCS Research, TCS Innovation Lab. So my most inclination is using like actually while working in TRDC, I have worked on range of research problems. So when I went to work with Tata Motors, where we were working on some engine coolant to improve their efficiency. Later, I shifted towards mineral engineering, like developing or synthesizing or formulating novel formulations for iron ore beneficiation. Then I shifted towards e-waste recycling. So over this journey, my research focus has been shifted, but the material aspect or the bottom line to design, to formulate, to scale up remains same. All these research problems were different, but the methodology was little bit similar. So why did I choose to do PhD after working in TRDC is the next question. While working in TRDC, of course, I wanted to do PhD at some point of time. While working in Basa's group, I was from that batch where many of my batchmates are currently working as a professor in different IITs. So I saw them growing. I saw them like how do they manage their work, how do they manage their time, how do they manage their research, and I saw that process. But then at that point of time, I wanted to get some industrial exposure. That's why I chose to work in TRDC. while working in TRDC, I was learning the same aspect. I was learning the similar aspect. I was at the position where other PhDs used to join, and of course from other international premier institute. And I saw them that they are contributing something else. In spite of my experience in the company, they used to bring something else to the table. So, and I could really relate well with the process that they have undergone for working for 4 years in an academic setting, uh, going deep and broad and getting those expertise really well. So that's why I decided that now I should get some exposure in academics. I should learn with, of course I could easily build on, and I could easily relate with the, and I could really think about it from my industrial experience, and I could really think more than the regular general fresh PhD student. So this I knew that this will be helpful for me. That's why I chose to do PhD.
Yes, sir. Thank you for sharing your valuable experiences with us. I next call Mahita to continue forward.
Next, coming to Akshaya Sundar ma'am. The question for you is, you have worked at various companies. So what has been the most productive period in your career and why?
Yeah, it's always a very difficult question to answer. So, I mean, I just want to give a brief career history of myself. So after my bachelor's, I joined an IIT to pursue Master of Science, not the MTech, but it was MS. So I was keen to do some research-oriented master's program. So in that, immediately after bachelor's, I had worked a couple of months as a process engineer in Biocon, which was a biotech company. I worked in the synthetic chemistry department. And then from there, I got the instead of doing research, everyone was in biotech, most of them are deep research kind of projects. So then I moved to pursue a master's by research. And then after my master's by research, I understood that I have to acquire a lot of industrial knowledge. That's how I joined in TU Delft for pursuing my professional doctorate. As I said, it's a very industrial oriented kind of doctorate program. And during the program itself, I had worked with different kinds of companies, and I eventually ended up in a startup where my thesis work was a base for the startup. So, and from the thesis work itself and building the startup, and up until now, I work for a project. Basically, I work for a green hydrogen related fuel based project in the startup. So up until now, from my thesis, I have been continuously working in a challenging environment, which is very dynamic and, which needs a lot of input from myself and within others. So, and as and in the startup, as everyone was telling, I was not just working as a chemical engineer, for instance. I had to work as a chemist. I was literally doing the chemistry experiments. I was doing I'm doing project management. I'm working with different vendors or collaborating with different people for, communicating and getting things from other places to the lab, or, all the things, all possible job you can take up as a chemical engineer in different domain, I've been doing for past 2 years. So that was my best period, I would say. So as a fresh person into the engineering domain or the chemical engineering field, I got an immense opportunity to, explore all kinds of possible things in the startup. So this period I consider as my best period. So there are ups and downs, but I personally am a very dynamic person who likes to work in very challenging environment. So this actually suits me. So it was okay. So I consider this as my best period. And that's what you asked, right? That is what, okay. So I think this is it.
Thank you for your valuable insights.
Just one comment, Mahita. So Aksha, do you think at certain stage it all comes down to getting things done? Like the boundaries between chemical engineering, chemistry, and other stuff becomes blurred, and it's in a company, it's like you just get things done and then you manage how you want to do it. Is it?
I mean, yeah, I mean, eventually we have to get things done, but I understood that if you do a chemical engineer or if you're a chemical engineer, eventually you can do all these things, because I had zero experience in doing chemistry experiments, that too organic chemistry experiments, but I'm doing it and I succeeded. So I guess if you are a chemical engineer, I guess you pretty much cover every aspect in the engineering domain or in the industrial field, which you have to apply. So you could get things that, I mean, things to get done. And yeah, that, I mean, this is from my experience, but yeah, it could vary. But that's what I think.
Thank you. Yeah, Mahita, you can continue.
Next, Harikarthik will continue.
Yeah, now to Sanjay Kumar sir. My question for you is, what makes chemical engineering special and unique in your opinion? And any useful knowledge that you gained at IITM Chem E, which is being used at JP Morgan right now?
Yeah. And again, please don't call us sir. It just makes us feel so. We're just recent graduates. so one thing is that I'm working in a quantitative finance role. So the one thing that I can immediately relate to is the courses that I took offered by the professors in the systems department. Courses offered by Professor Arun Tangirala, Professor Shankar, Professor Sridhar, Professor Niket, Professor Nirav. Like the entire systems group, they have excellent quantitative courses. Even one of my BTech project was under one of the professors there. So that helps me massively, because even from a hiring perspective, when we are looking to hire fresh undergraduates for quantitative finance role, we look at three main verticals. We look at the math aptitude, we look at coding, and we look at how much of finance they know or derivatives they know. So one thing that I can tell you is that it's easier to train any person on the finance or derivatives part. We can get that person up to speed in a month. It takes slightly longer to train a person in the coding aspect. It takes 3 to 6 months for a person to become a good coder. And it takes years for a person to understand the math required to do well in the role. I was lucky to have taken the right courses, or the courses with enough rigor for me to understand anything that comes my way in my current job. So that was one main aspect of just chemical engineering related part. And the second is that like even within the core curriculum of chemical engineering, it's quite quantitative. You are often thrown with several differential equations and so on. The entire quantitative aspect of chemical engineering is what's helping me in my day-to-day work.
Yes, sir. Thank you for the technical information you gave. Now I again call Mahita to carry forward.
Next, coming to Pranit. So next, coming to Pranit Srivan, how do you feel about translating your research into innovation?
Okay, it's a very good, pertinent question given my foray into applied research over the years. So let me, talk about it in very briefly, because it's quite a big topic. To quote what my current company's founder used to say often in our meetings, he says, it's very difficult to integrate scientific possibility, technical viability, and commercial feasibility. So the first aspect, scientific possibility, for us to get something to work, a proof of concept of an idea, to kind of make the science work, that is the research part of it. And in different domains, the time it takes for a scientific possibility, for us to get a proof of concept, it can run into years and decades. So the discovery phase, for instance, the project which I have been working on, development of biodegradable polymers, it's a very long-term project. Just getting the science to work of it, the biodegradable polymer, it's not just that if it's biodegradable, it can be put to use. It should have the same strength as a normal plastic. It should not degrade during the use, like during the shelf life of it. It should have a long shelf life. It should be stretchable. It should be able to bear the weight of whatever. If you have to, the usual stuff which are put into a plastic bag, same biodegradable bag should kind of hold. So for all these properties to be met, there needs a lot of work to go against the chemistry aspect of it, behind the processing aspect of it, the engineering aspect of it. And that is the science part of it, the research part of it. Now, once all this scientifically, we kind of, get the numbers right, get the correct properties, get the desired technical specifications right, then the question comes, in terms of, can we do it at a large scale? Is it feasible for all the raw materials to be procured in a consistent manner? Are there any regulatory constraints that we run into? Like, would use of any of these chemicals in a 100 kg or 1000 kg mini pilot plant cause a lot of toxic waste streams to be produced? In what level do these kind of contribute to the greenhouse emissions? You can keep going into all that. So that level, it's again a challenge. A little bit of scaling up from the lab to a pilot plant and assessing parameters in a pilot plant in itself is quite challenging. But let's say if you kind of, work around it, make modifications in the way things are done so that it kind of meets up all the requirements at a pilot plant or even a larger scaled up plant, then the possibility of making a commercial impact. So here is where, costing comes into picture. So costing, unless our product, any innovative scientific product that you're trying to make is cost competitive, is something which will, stand for itself in terms of, being able to generate a consistent revenue stream. It will be very hard for a very innovative, scientifically well-proven product to stay in the market. And this is something which I have learned that, the costing aspect, the finance part of it, how exactly you would kind of compete with other, products in the market. Does the science aspect of it in itself appeal to the people? Because many people, the lay people who buy it or the business people who are involved in transactions at the commercial level, they might not care a lot about the science aspect of it. It's only the research people and engineers who are so much, science oriented and technical aspects oriented. So that kind of has its own barriers. So this translating research into innovation, it's a long journey. And I should say that if a person, a current student is kind of very enthusiastic about doing translational research, a good place to start would be to kind of interact with a lot of subject experts to get to know which particular field or subdomain within chemical engineering has a faster possibility for the translation. Maybe if they're very eager to see the translation in action, they can choose some problem which has that scope, inbuilt to it, compared to a problem which takes decades to go for. If you have any questions on this, as I say this, I'll be more than happy to answer.
Thank you, Pranit, for the wonderful insights. And I think during student life, many of us just think about the, as you said, science aspect of the subject we are learning. But when we go to real market and join any company, startup or established, one of the main objectives is making profit, if that is not the only objective. And when it comes to profit, then I think as a student, we need to understand how market works, the costing involved, and how do they make money from selling that product. So a very good point. So with this, I would thank all the panelists to share with the utmost honesty and this very wide range of experiences with all of us. I want to summarize a few things which I really liked. Is that in chemical engineering, the students learn a lot of wide variety of topics. As Sanjay was saying that the differential equation, the maths that you learn can be used in quantitative finance. You'll have a little bit of chemistry, little bit of mechanics, little bit of mechanical engineering. We can just go anywhere. I've seen people working in a chemical engineer working in Intel in the semiconductor industry. They are working in all kinds of stuff, making glass and ceramics. So this thing that if you choose in chemical engineering, then you are stuck doing just petroleum or oil and gas. That is not the end of chemical engineering. That is the most traditional way of where chemical engineering has contributed a lot. But these days, the possibilities are vast. And also another point that while what type of company to choose, I think at the age of during undergrad, we look at what looks cool and what is more interesting. We sometimes don't think that whether I'll be comfortable in that position or whether I will actually enjoy day-to-day life working in those type of companies. So that is something listening to all of you, I've realized that students should maybe talk to people who are already working in the company. What is the day-to-day life rather than just the coolness factor of that particular job. So with that, again, I'd like to thank all the panelists as well as the volunteers, student volunteers who have been working days and night for the last several weeks, if not months, to organize all this ChemPlus event and this Chemi panel. Thanks Mahita, thanks Hari, and as well as Soumya, who has been coordinating for this entire thing. Thank you all. Have a good day.
Thank you.
Yeah.
Thank you. Thank you, everyone.
Thanks, everyone.
Thank you.